Hello everyone, welcome back to my channel Learn with Mukul. So in this video I am going to teach you about the basic concept of CPU scheduling algorithms. So in this video I am going to teach you what are the algorithms which is used in CPU scheduling, which are basically FCFS, SJF and round robin algorithm. FCFS stands for first come first serve, SJF stands for shortest job first, and third one is round robin algorithm. So basically CPU scheduling algorithm means it is a process of determining which process will own CPU for execution while another process is on hold. Like suppose there are two processes. If process 1 requires 10 seconds and process 2 requires 5 seconds, if the CPU had decided to complete one particular process, suppose P1, so it will give 10 seconds to complete that particular P1 and keep that P2 on hold. This is how CPU scheduling algorithm works. So there are basically two types of CPU scheduling methods. First one is preemptive scheduling, second one is non-preemptive scheduling, and which is also called no interruption, and preemptive scheduling, which is called interruption. Means in preemptive scheduling there is an interruption, there is a breakage while the process is being executed, and on second, which is non-preemptive scheduling, which means there is no interruption while the process is being executed. Now there are some important CPU scheduling terminologies which you should know while dealing with the numericals of these three types of algorithms. So first one is burst time. So it is a time required by the process to complete execution. It is also called running time. So basically burst time means the total amount of time taken by the process to complete its execution. So it is also called running time. So it is called burst time. Second is arrival time. When a process enters in a ready state, it's called arrival time, which means when the process first came at a CPU, so it is called the arrival time. What is completion time? At what time the total execution has been completed of the process. Completion time, at what time the total execution has been completed of the process, which means at what time did the process has been completed. Fourth one is throughput. Number of processes in per unit time by CPU, means the number of processes which can be executed in per unit time by CPU is known as throughput. Fifth one is waiting time. For how much time the process has to wait in the queue. Suppose there are two processes, P1 and P2. P1 requires 10 seconds and P2 requires 5 seconds. P1 came first, so CPU will deal with P1, and for 10 seconds it will keep on executing P1, and till that time P2 will be on hold. So how much time the P2 is on hold, it's called the waiting time. Now there are three, I have already told you there are three CPU scheduling algorithms, which are FCFS, SJF and round robin algorithm. So I'm going to teach you all of these three algorithms one by one. So there will be three videos of this playlist. The first one will be FCFS, then SJF, then is round robin algorithm. So today I'm going to teach you about the third most easiest concept of CPU scheduling algorithm, which is round robin algorithm, or you can say it is quite a bit difficult from previous videos of FCFS and SJF. So today I'm going to teach you about round robin algorithm, so which is also called double R algorithm. So let's jump back to the numerical. So as you can see, in round robin algorithm the criteria which is followed is time quantum, and the mode is preemption, which is quite different from the previous algorithms, which is FCFS and SJF. In preemption there is an interruption while the process is being executed for a particular process. In round robin algorithm, make sure that the time quantum is always 2. Make sure that the time quantum is always 2 for round robin algorithm. Remember this. Now there is a point to be noted in round robin algorithm, which is the ready queue is directing towards executing queue, and executing is vice versa directing towards ready queue, which means if a process is in ready queue and it's not completed yet in the executing, it will return back to the ready queue. I hope you are understanding my idea. What I am trying to say is, if the process is in ready queue and it's went to executing queue, if it is not completed because of the preemption mode, the context switching occurs, it will return back to the ready queue. I will explain this point to the following numerical, which is the five processes which is already given to me which is P1, P2, P3, P4 and P5, and there are 5 things that we need to cover in this algorithm, which is completion time, total arrival time, waiting time and response time, and complete this Gantt chart. Now first of all, to complete this round robin algorithm numerical, we need to know some formulas. The first one is RT, which is response time is equal to CPU first minus arrival time, total arrival time which is equal to completion time minus arrival time, and waiting time which is equal to total arrival time minus burst time. Now as you might have a doubt, what is CPU first? CPU first means the first interaction of the process with the CPU is called CPU first. Now we are going to start this particular numerical of round robin algorithm. So see, in round robin algorithm, the thing that you might need to know in your mind that the time quantum is 2, which means there is a preemption. So how you can do this? First of all, make a Gantt chart which contains 2 things, which is ready queue and executing queue. Now you always know that the ready queue always starts with 0. Now the arrival time is 0. See, at 0, is there any process which has arrived at 0? Yes, you can see here it's P1. So right here P1, there is a process which has arrived at 0 in arrival time, which is P1. Now executing queue, as I have already told you, ready queue is directing towards executing queue, and executing is vice versa directing towards ready queue, means it's kind of a loop. Now ready queue, at 0 interval of time there is P1, so it will execute now P1. So right here P1, and how much time does P1 require to complete its execution? Here it is 5, but you will not write here 0 plus 5, but there is a preemption, which means there is a breakage, which means the CPU will only give that particular P1 process only 2 units. Okay, so 5, here it is requiring 5, so 5 minus 2 is equal to 3, so it will become 3, and here it will become 0 plus 2 is 2. I hope you get the first step of round robin algorithm. I'm trying to say is there is a preemption, there is a breakage while the process is being executed, because the time quantum is 2, so it will execute only 2 seconds by the CPU. So 0 plus 2 is 2, and the remaining time here was 5, so 5 minus 2 is equal to 3. Now is our P1 completed? Not yet. Now look what you have to do. Second step, don't go for ready queue. Now the second step that you need to do is check, is there any process which has arrived between 0 to 2 interval of time? I am trying to say, is there any process which has arrived between 0 interval time to 2 interval of time? Check upon the arrival time. Yes, we can see here it is P2 and P3. P2 came first and then P3. So right here P2 and P3, P2 and P3. Now we have written the process which has arrived within the time period of 0 and 2. Now was our P1 process completed? No, so we will keep that P1 after P3 to get execute. Now this is the second step, P2. Now after P1 it's P2. Now P2 requires how many time to get executed? It's 3. So you will not write 2 plus 3 5, you always give 2. So 2 plus 2 is 4, because the time quantum is 2. So P2 required only 2, 3. P2 requirement was 3, but it is only executing 2, so 3 minus 2 is equal to 1. I hope you are getting my idea or the concept logic that I am putting here in round robin algorithm. So to understand what I am trying to say, keep a notebook with you, so that do with me how I am trying to explain. Okay, now P2, after P2 is completed, now check, is there any process which has arrived between 0 to 4 interval of time? Again the step 1 will be followed. There are only 2 main steps in round robin algorithm. The first one is check what are the processes which are coming in 0 to 2 interval of time, and second is the processes which are not completed will be executed at the last. Okay, now check for process, is there any process which has arrived between 0 to 4? 0 to 4 it's all processes which are coming. So our P1, P2, P3 are done, so it will be P4 and P5. So right here P4 and P5. Now was our process P2 was completed? Because while we were executing this, the requirement was 3, we have executed only 2, So was the process P2 completed? So right, we have wrote here P2. Now now comes the time of P3. So right here P3 and now P3. So P3 here, it is requiring only 1, but CPU is giving 2, so only 1 will be needed because it is less than 2. So 4 plus 1 is 5. Now is our P3 done? Yes, it's fully done. Now this will become 0. So our P3 is done. Now again comes the time of P1. So right here P1. So P1 is requiring 3. So but the CPU is giving only 2 seconds. So it will be 5 plus 2, 7. So it will become 3 minus 2 is equal to 1. Now was our P1 completed? No. So it will again go back to the ready queue P1. Now comes the time of P4. P4. How much time does P4 require? It's only 2, which the CPU can handle. So it will be 7 plus 4, 9. So P4 is done. Now P5. Now P5 requires 3. So right here P5, and it will be 9 plus 2, 11, which is more than the CPU time. So it will be 3 minus 2, 1 is remaining. Now is our P5 completed? No. So it will go back to the again ready queue P5. Now P2. P2 requires only 1, so it will be 12. P1, P2 12 required, so it will become 0. So P2 will be done. Now P1 requiring only 1 second, so it will be 13. So P1 is also done. Now P5 is left on with only 1, so P5 will become 14. So with this our P5 is also done. I hope you got the concept of this round robin algorithm to complete this Gantt chart. Now I'm again putting the value of burst time because I have wrote here 0. So the burst time for P1 was in RT. So burst time was 5 for P1, for P2 was 3, for P3 was 1, for P4 was 2, and for P5 was 3. Now we will complete the following table. CT. So completion time for P1. So look at the executing queue. While dealing with CT, TAT and WT and RT, you always have to look to the executing queue table. CT. P1. So P1 got completed at 13. So CT here becomes 13. Check for P2. P2 it's 12. You might have, why not 11? Because P2 got the time at 11 to the CPU and got completed at 12. Okay. Now P3. P3 it's 5. Check where it's P3. Yes, it's P3. It's 5. P4. P4 it's 9. P5 it's 14. Now which will be 13 minus 0 is become 13. 12 minus 1 is 11. 5 minus 2 is 3. 9 minus 3 is equal to 6. 14 minus 4 is equal to 10. Now waiting time. 13 minus 8. 11 minus 3 is 8. 3 minus 1 is 2. 6 minus 2 is 4. 10 minus 3 is equal to 7. Response time means CPU first minus arrival time. So this is quite critical. Now check. P1 got first interaction with the CPU at what time? At P1 it's 0. So 0 minus 0 is 0. For P2 it's 2. So 2 minus 1 is equal to 1. And P3 4. So 4 minus 2 is equal to 2. And P4 7. So 7 minus 3 is equal to 4. And for P5 it is 9. So 9 minus 4 is equal to 5. So this is how we have completed the numerical of round robin algorithm. Now to calculate the average waiting time. To calculate the average waiting time, we need to do the sum of all this average waiting time. Sum of waiting time divided by number of processes. 16 plus 2 is equal to 18. 18 plus 4 22. 22 plus 7 is equal to 29. So 29 divided by 5 comes out to be 5.8. So the average waiting time is 5.8. So you can see this is how the numerical of round robin algorithm is done. I hope you like my video. If you like it, then please like, share and subscribe, and do comment on my video and help me reach 1K subscribers. So thank you, meet you next time.